Assalamualaikum and hi everyone. So today we are going to continue our lesson for our final chapter 5 entitled The Application of Integrations. So today we are going to focus on subtopic 5.1, which is the area of a region. So at the end of this lesson, you should be able to apply the definite integrals to find the area of a region. Integration actually helps us in finding the area under the curve of graph. Basically, we have two cases for area under the curve, which is case 1 is that the curve which are entirely above the x-axis. So basically, we have the lower limit of A and the upper limit of B. Then we have to find a region bounded at the graph curve here. And then case number 2 is that the curve which are entirely the right side of y-axis. So basically, as you can see here, the lower limit is C up to D. Then we have to find the region bounded by the graph curve of x is equal to gy at the y-axis. And then let's see for the case 1 first. Okay, case 1 is that the curve which are entirely above the x-axis. So the formula given is that the integral of a up to b fx dx. So let's look at the example 1 first. Find the area underneath the curve y is equal to x squared plus 2 from x is equal to 1 to x is equal to 2. So as we can see here, this is the region bounded at the curve of x squared plus 2 at the interval of 1 up to 2. So by using the formula, we know that a is equal to integral 1 up to 2 x squared plus 2 dx. So we have to integrate this function. So we get x cubed over 3 plus 2x, and then the lower limit from 1 up to upper limit of 2. Then we substitute 1 and 2 in the integration function that we have integrate, and then we get the final answer as 13 over 3. Moving on to the case 2, the curve which are entirely right side of the y-axis. And the formula given is a is equal to integral c up to d gy dy. So the main difference here is that case 1 using x term and case 2 using y terms respected to the axis that we use. Okay, example 2. Find the area bounded by x is equal to 4 minus y squared. The y-axis, the lines y is equal to -1 and y is equal to 2. Okay, now we have the parabola functions, which is the quadratic function, which is x is equal to 4 minus y squared at the y-axis. Then it is bounded at the interval of -1 up to 2. So by using the formula, a is equal to integral from -1 up to 2 4 minus y squared dy, and then integrate, substitute -1 and 2, so we get the final answer is 9. How do we want to find the area between two curve or line? So let's say for this case, at this graph, we have two curve, which is y is equal to fx and y is equal to gx. So basically, we want to calculate the shaded region here, and then we have to minus gx so that we can remove this part of area. So the formula given will be a is equal to integral a up to b fx minus gx dx. Let's look at example 3. The diagram below shows part of the curve y is equal to x squared plus 2 and the line y is equal to 4 minus x. Find the area of the shaded region. Okay, so we have the parabola function and the straight line of y is equal to 4 minus x. And then as you can see, if we integrate y is equal to 4 minus x, we get this part of trapezium shape like. And then actually we have to remove this part of area. So basically we have to minus with the parabola function, which is the quadratic function of x squared plus 2. So we have a is equal to integral of -2 up to 1. And then in bracket 4 minus x, which is the straight line function, minus with the parabola function, which is the x squared plus 2. And then integrate it, we get integral we simplify it, so we get -2 up to 1 integral 2 minus x squared dx. and then we integrate it, then we get 2x minus x squared over 2 minus x cubed over 3. Substitute the interval value, so we get final answer of 9 over 2. And then how about the area between two curves or lines that is bounded at the y-axis? So it is the same formula like the x-axis, but it's in the y term. So we have integral a up to b fy minus gy dy, as we have to remove this part of area, so that's why we minus gy here. Okay, so let's move to example 4. Determine the area of the region enclosed by 2x minus y is equal to 2 and x plus y squared is equal to 4. So we have a straight line 2x minus y and also the parabola, which is x plus y squared is equal to 4. But we have to find the point of intersection here so that we can integrate it later. So we have to solve the point of intersection. So we have to equal the line function is equal to the parabola function or the quadratic function, and then we move all the y term and all the expression at the left hand side, and then we factorize is equal to 0. Then we get the y value is negative 2 and the other y value is 3 over 2. If we substitute back, then we get x is equal to 0 and 7 over 4. So the graph intersect at this point, and after that we can use the formula, which is a is equal to integral from negative 2 up to 3 over 2. Okay, from here actually we have to find which one have to subtract. So the right is the x plus y squared is equal to 4. So actually we have to make it as a y term. So we get 4 minus y squared, and then we have to subtract with the straight line, which is 2x minus y is equal to 2. Then we let as x is equal to in y term, so we get 1 plus 1 over 2y. And then we simplify, we will get the integral of negative y squared minus 1 over 2y plus 3. We integrate, then we get negative y cubed over 3 minus y squared over 4 plus 3y. And then substitute the interval value, then we will get the final answer of 343 over 48. So that's all for today. Let's check your comprehension.